but you make a team out of, like, whatever players you want. So, like, I had the Kansas City quarterback on my team this season. He's good. Just didn't play well last night. He is good. He's normally way better than that. Yeah, it was boring, and I kind of stopped watching. So, the Super Bowl happened. That's a thing. More importantly to you, I have notes, right? So I put notes on every desk here. Please put your name on them. If you still want to get out graph paper, that's 100% fine and completely up to you. But you probably don't have to. Everything we do today will probably fit on this. So with that, I would tell you, you should probably get a binder. Because if you just have a notebook right now, what are you going to do with this paper? Like, glue it in, but it's front and back? So that wouldn't work. Just, like, stick it in there and hope it doesn't fly out? Like, that isn't a great idea. So you could, like, staple it in, right? That's an option. But what I'm telling you is you should get a binder. Your life will be easier if you just decide to go ahead and get a binder for math. It was on the supply list. So no excuses. If you don't have one, tell your parents to get one. They're on Amazon. It's pretty easy. Huh? Yeah, and they're at, like, the dollar store, too. So for anyone thinking, like, well, we don't, like, shop on Amazon, that's fine. Go to the dollar store. We have some 2-inch binders from school that I could give you. They're a little bit bigger than what you would really need for math. But if you need a binder and you don't think you're going to be able to get one, let me know. Like, shoot me an email. I can get one from the office and get that to you. But to dive in, sorry, I didn't want to show that yet. Let's talk about that quick review. So go ahead and on your notes there, solve that quick review from last week. Make sure that you have your name and the date on your notes. Even though we're not working on graph paper, we still need name and date. It's always up on the board, guys. What am I trying to remind you with this quick review? What are we doing, first off? What's the word that describes what you're doing here? Yeah. You found that really funny, didn't you? You're right. Like, yeah, it is math. The part of math that we're doing here is not factoring. Be careful, because that vocab word is on here, and we're going to remind ourselves what that means. But right here, when we draw the arrows, I'm trying to remind you that it doesn't matter what way we go. I should use blue, since you guys are blue, so I can remember what day I did things on. So remember, we draw the arrow to each other number, so we should have 3 arrows here. And then I know I tell you guys to work vertically, but because this vocab word is here, I'm actually going to move over to the right. So sorry if you wrote down here. That's okay. You can kind of make your words dip down. So -8 times m. -8m. I'm going to put that in parentheses just to keep it nice. What's -8 times -3? What, Stella? Hold on. Because the 8 is negative. So -8 times m makes the -8m. -8 times -3, though. A negative times a negative? Positive 24. And then -8 times 4. And, well, that's going to become negative again, right? Because we have 1 negative. 32n. So that's what that becomes. Can we combine any of these numbers? No, why not? Because they're not like terms, right? So because they are not like terms, that is why we cannot combine them. Since you guys are in here now. All right, what is factoring? Who can remind us what we said last week factoring is? If you can't remember, look in your notes, because you should have it written down in your notes. That's why we take notes. Remember, there's a notes check this weekend. I know, I'm trying to deliver a lot of information. You mean an auctioneer? Hey, I got your math this morning. Who wants the math? Going for the math. We'll take the hybrid. Or Nate's got that. They actually are saying words the entire time. They aren't just like mumbling. They are actually saying words the whole time. No one remembers what factoring is. We're going to sit here till somebody does. Stella? Yeah, dividing expressions. And we also said, like, another thing we can talk about is, like, breaking them apart, right? But factoring, we are going to pull out or divide. So please, right here, write our definition. Dividing by a common, zoom out a little bit. Dividing by a common factor is really what factoring has us do, right? Like the action that we are going to do. So I want you to take a moment and look at these 4 expressions down here, right? If you want, you can draw some vertical lines to split this up. And think what number could be divided by both of these. So I'll go ahead and help you with the first one so that you know what you're doing. Where's my little ruler? So I'm going to separate this to make sure that I keep some clean workspace. What? I have no idea what's going on right now. Happy Monday. So first off, I have 2 negative numbers here, right? So the first thing I notice, even though this looks like a minus, is I have 2 negative numbers. And guys, if you want to see like what I'm referencing, it's exactly like what Khan Academy is going to give you, except notice that there is a like choose 3 answers. So it's a little bit harder because there's multiple right answers. So I think about what could I divide both of these by? Now, in my head, I'm like, they end in 0. What does ending in 0 mean? 10. They could divide by 10. And since they're both negative, I could divide by negative 10. So let's imagine this. If I divide by negative 10, each of them, well, negative 90 divided by negative 10 would give me 9. And I know that because if I think about the distribution, that would make negative 90. Negative 10, if I divided that from negative 60, well, again, it's going to become positive because negative divided by negative. 60W, well, hang on to the W, like bring it with you in a minute, but what's 60 divided by 10? 6. And if you think about the other arrow from our distribution, that would make your negative 60W. I want you to think of at least one other number that we could factor this expression by that's not negative 10. Negative 30, I'm going to write this in a different color actually. Can you give me like 30 seconds to finish this one? So please make sure you're writing this down with us. If I divided negative 90 by negative 30, what do I have left in here? 3. And if I divided negative 60, hang on to the W, like bring it in a minute. Negative 60 divided by negative 30, 2. And then we got to bring the W with us. We can check it by looking at the distribution. All right, Natalie, go ahead. Just wanted to make sure that you saw that we can get 2 different answers. So that one was in the multiple choice list over there. Is there another one that would work? There's got to be, right? Because what about 10 times negative? Ooh, if our 10 wasn't negative, right? What if it was positive is what this is saying. What's 10 times negative 9? Negative 90. What's 10 times negative 6W? Negative 60W. The second one here would work. What about the third one? Negative 3 times 30? That works. Negative 3 times negative 20? Uh-oh. That becomes positive. So that would not work because that becomes positive. This is all positive. So I don't know why my little toolbar is blocking the view. But I think it's going to be our final option down here. So remember that All because the numbers are not super nice does not mean that it's not your option. So think about what is negative 20. Still blocked. Negative 20 times 4.5. And you could check it in a calculator if you want. And do negative 20 times 3w. I bet it works to come out to be negative 90 minus 60w. So try the next one on your own. I'd rather you honestly just be looking at this. Try this on your own. We cannot put those numbers together because they're not like terms. So instead, we're going to factor them and break them apart. Guys, I'm trying to make your life easier by giving you notes now that we're back at school. But I still need a lot of effort from you, right? I need you trying these questions. If you don't know how to do it, I need you asking me, hey, how do you do that? Huh? I mean, can they both divide by 7? Can 56 divide by 7? Oh, yeah, okay. So if we did 7, what we ask ourselves then is, what do we have left? Well, 7 times, you guys just said 8, makes 56. I got to bring the z. What else do I need to bring? The negative, because to make negative 56z, one of these has to be negative. Then, if the 28 divided by 7, 4. Now, actually, if I wasn't trying very hard, what I notice is, oh, that ends in 6, oh, that ends in 8. They're both even. I could factor out a 2. All right, if I factored out a 2, this would be negative 28z plus 14. Something is stabbing me through my shoe. Yes?
Can't you do it the other way too on the first one?
What do you mean the other way? I mean, probably yes. Short answer. I want you to explain yourself, but the short answer to what you're saying is probably yes. There's a bunch of ways that these work. Ow! I think it's a piece of firewood. This splinter was in my boot. Ow! That's painful. Glad I figured that out. All morning, I'd been like, something is poking me. Like, why do I feel like something's poking me? That makes sense now. But yeah, so there are a bunch of ways. If we made the 7 negative, then the 8z would be positive, the 4 would be negative. Same thing if I made my 2 negative, so I can flip the signs around. Guys, this is why the first stuff I ask you to do on this in con is multiple choice. That's why the first stuff I have you doing is multiple choice. So let's look at this one together. You just did it on your paper, but let's ask ourselves, do these things work? Half of 28, oh no, wait, that's silly. Half of 28, that wouldn't work. 40, I'm going to avoid this because it's decimals. For a second, I can come back if I need to. Negative times negative z, oh crap, that's positive. That doesn't work. Negative 7 times, ooh, this is what we did. Except they swapped the signs around. Guys, check it. Look, negative 7, we did positive 7. 8z minus 4. Yeah, that works. This is what Nate was thinking, right? Do it the other way with like the other signs. Do we have questions on what we're doing here? You can also use a calculator to check these things. I want you to do the next 2 on your own. They're smaller numbers, so there are less options of what to factor by because there are smaller numbers. And then, guys, I'm using a randomizer to pick one of you because I still need to make my cards. I may just do that now while we're having class, actually. Might make my cards. We should be working, we should be factoring. And you can see the rest of the notes If you get done, you can go ahead and move on and look at the next thing that we're doing. Challenge yourself. See, can I do this? Isaiah, what could we divide 6 and 18, right? Because we're going to ignore the variables for a moment. What can we divide 6 and 18 by? Yeah, they're both even, sure. Let's do 2. 2, so what do I have left? Well, 6g divided by 2 would give me 3g. Negative, okay, bring the negative, right? Or the minus, if you want to call it a minus. What's 18 divided by 2? 9, and then bring the h. Martin, give me another number we could divide these by. Huh? 3! So 3 gives me 2g left. Minus, what's 18 divided by 3? 6. Anyone have questions on this so far? Class answer, what number kind of jumps out at you that we could divide by here? 5, right? They all end in 5 or 0. So we can divide by 5. Be careful with your signs, right? This is positive, so it stays positive. 30s, well, the s will come in a minute, but 30 divided by 5, 6. Sorry, my 6 looks a little goofy there. Bring the minus or the negative, depending on what you want to call it. 45 divided by 5, 9t. Is there something else that we could divide everything there by? I don't think so. Right? So sometimes, guys, there's only one. Well, unless we start thinking about fractions, right? If we use fractions, we can do whatever we want. But if we're trying to use whole numbers to break things up into groups, the only way that makes sense is to split this into 5 groups. Because if we want even groups, not even the number, but even like the same size. Questions on these problems? Otherwise, you can tell we're moving on to different stuff. Yeah. You can always double check these by doing the multiplication that you would do for the distribution. So another way that you can remember factoring, it's the opposite of distribution. If you want to write that down, factoring is the opposite of distribution. It's undistributing. But now we get into the slightly more complex distribution problems. Simplify these. This is also a tiny bit of review from last week. So take a moment on your own. Try to simplify those 3 expressions. I'm going to split my page up, which, if I was you, would not be a bad idea. Grab one from up front. They're in the bin by the highlighters if you want to borrow one. Yeah. Because then when we wipe our desk down, you can wipe the ruler and the highlighters or whatever down. Remember, we're back at school now, which means I have resources for you. I am here to take care of you. What number is getting distributed? -5. -5. Be careful. So the negative f, I'm just going to bring down. Careful, the -5. Now I'll be quiet and give you guys a moment. I should see pencils moving because there are 3 problems to do there. And then there's even another one at the bottom where we're going to talk about like options. I would argue, actually, that the first one is almost the trickiest here. Hey, Lily, you done with these? So, go ahead and help me then. What's negative 5 times 2f? Yeah, and if I want to be nice, I should put it in parentheses. Negative 5 times negative 3? Ooh, careful. Positive 15. Because negative times negative. So, guys, check your signage here. Negative f, negative 10f, positive 15. So then, are there like terms to combine? Yeah, variables or constants? The variables, right? The f's. So negative f and negative 10f. Negative 11f. Oh yeah, don't forget the plus 15. So I could put that in parentheses if I want to be nice. Just a construction dude. He looks like he's getting ready to go up on the lift. I know. So, the thing I wanted to make sure I reminded you guys about here, does this 3 multiply by the 3a? No, that addition happens after. So, be careful with that. I'm seeing some people tempted to make that multiplication stretch across. So, we get negative 6a. And then, yeah, thank you. I appreciate the participation. And then still plus 3a. What do we do now? Yeah, add the variables together. But do they get along or fight? Oh, man, they fight. What do we get when they fight? Yep. So obviously it sounds like Lily knows what she's doing. Does anybody have questions on this? Sydney, Natalie, you guys are really far away. Well, you're not really far away. You're a lot closer than you were on Zoom. But are you guys doing all right over there? Yeah? All right. Last one here. I'm not going to work it out with you, so I'm just going to quietly solve it. If you need help, look at the board. If you don't need help, wait till you get your answer, then verify your answer at the board. Oh no. Yeah, that's the problem. I would advise not taking notes in pen since we're doing front and back. So I have extra pages of notes, but this is the back of my paper right now. So if you're using pens or if you highlight too heavy, it might bleed through, and I'm not going to give you a second sheet. I'm sorry, but that would be a lot of paper for us to use. Probably maybe. Except notes might have like 2 days worth of notes on them, which really would then be like the week for us in hybrid. I don't like using tons of paper, but I realized for me to move at the speed that I need to move to finish the school year, you guys need to write less down, right? Like, so I'm trying to help you guys out. So help me out by doing your Khan Academy and like sending me emails when stuff doesn't make sense. Like, we're on the same team, right? So please, let's all play together. Let me help you if you need help. I get a negative 4H, a negative 20, and a positive. Ooh, what happens here? They cancel each other out, or they fight to the death. No. Well, it becomes negative 20, but yes, there are 0 H's because the good guy and the bad guy battle each other till they're so tired they both just go home. No one wins. There are no H's left. They just go home. They don't fight to the death. They just go home. Everyone's like, where'd the H's go? And they're like, yeah, those dudes like punched each other for a while and then they left. Yeah, tell me about it. I don't, though. All right. Huh? Monday's President's Day. When I was a kid, it confused me so much that Martin Luther King Day was in January, yet February was Black History Month, and like it always confused me. But yeah, Monday's President's Day, not Martin Luther King Day. That already happened. Check these out, guys. Why are these trap doors? Who can tell me, like, if you've already worked on your Khan Academy? That doesn't make it any bigger. I don't understand that. Who can tell me why these are trap doors? Excuse me. I can't hear you. It doesn't tell me how many I'm supposed to choose. So I'm left to have to figure out each of these, does it work or not? Guys, I know I'm not super interesting, but a lot of you seem more interested in the highlighters than our math right now. You should be trying this. So the first thing that we need to do is figure out what does this expression actually equal, and then figure out what do each of these expressions actually equal. Well, none of the above. That's not an expression to figure out. But up here, arrows, right? Negative 6w, negative 18, which I could just write as minus if I really want. The minus 4 is not impacted by the multiplication. What do we get when we combine like terms? Yeah, negative 6w and a negative 22. Right? So we get a negative 6w. So now we have to see, do these expressions equal the same thing? Well, no. A is right out. So because of the negative 14, A's out. But darn, here we have to do the multiplication. Does this get you negative 6w?
Yes.
Does this get you negative 22?
Yes.
Ding, 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 ding. We have a winner.
Why are you so dense?
Try the other one on your own. Because the print, just how it copies over. Again, only look at the board if you want help. You looking up right now kind of tells me that you're still a little rocky with this. Otherwise, you should be doing it on your own. What do you guys think? A, B, or C? Four times negative 5. Negative 20. Bring the Z with you, right? Because that's actually how that works. 4 times 2, positive 8. Negative 6 and positive 8 fight, so we get a positive 2. So A does not work. But guys, B, what is 2 times negative 10Z? Negative 20Z. What is 2 times 1? 2. B. B as in boy. B as in Buccaneers won the Super Bowl. B works. A does not, because the 2 is negative. I did not actually mean for both of these to come out to be B, but, well, that's a 1 in 3 chance, so. There are only 3 options there. That does not mean each of these will be B when you go do your Khan Academy. Please do not think that. Flip to the back and double check that your name is on this, because, hey, you might lose your notes. Especially if you don't have a binder yet. Lily's like, I know what's going on. I got a binder. I'm having a good Monday. You sound like you know what's going on. Nah. Besides that, sun's coming up. Why what? Well, okay. I'll explain that, but also you should not, like, that should not be a thing this year because you're only in school every other day. But it's so we can fit in everything that we want to do, like extensions and AO, and make sure that you guys have wellness and everything else. All right, so let's look at the back. Not sure. That's still getting figured out. Linear expressions, and honestly, I don't know why, but like, I feel like when it's up here, you guys don't pay as much attention. So we might as well look at what's on your paper. Linear expressions are an expression that tells us a starting point and a change. That change is our unit rate. You might highlight or underline that the change is the unit rate. So I'm going to go ahead and take a highlighter and just highlight those words together. Change is the unit rate. And so we figure out what's happening to the output as the input changes. Guys, input, if you want to make a little note here, input is almost always your x. So when we're talking about like what's happening to your x or what is the x, x is almost always the input. So we call the starting point the Y-Intercept. Yeah, you got to write this down. But it's a lot less to write down than like last week, right? You're welcome. As we learn more about this, we'll call the unit rate the slope. So if you are ever talking with Math 8 kids or like older siblings and you start talking about linear expressions, they will probably start talking about slope-intercept form, which is a way that we write the expressions. But I just wanted to get that down. Now we're going to take a step back and look at like, well, why, right? Why are we using linear expressions? So the next homework that you have in Khan Academy after like what we literally just did, and it's due tomorrow. Guys, I'm not going to go in and change the due date, but I'm going to give you till like Thursday to get that stuff done. It takes a lot of effort for me to go in and change the due date because I have to do it for every class, and it's a whole thing. So the last 3 things on this week, I'll give you till Thursday on because it's the new stuff, but everything about factoring and distribution needs done by tomorrow. So we'll look at that at the end of class to make sure you guys know what's what. But check out this situation. Just take a moment and read this. Anyone want to read it out loud? Go ahead, Natalie. R. Thank you. So R minus C, when they tell us R is the robin, C is the cardinal, what is R minus C? So think about it for a second. Hold on, just think. So you're right. That's gonna be the label of it. But what R minus C represents is the difference. Guys, it's a subtraction. Remember, back to elementary school, subtraction means difference. So it's literally the difference. Please write this down. It's the difference between the robin and the cardinal. So I don't have space to write cardinal, which is sad because I am a cardinal. Otterbine's mascot is the cardinal, so sorry if you are a wolf and if that upsets you, well, it shouldn't upset you. So guys, when they bring in the t times, the difference just gets multiplied. So the expression t times r minus c brings in how long has this been happening. So if they both start flying from the same nest, well, this is kind of presuming that the robin is faster, but we're not sure actually. All right, you on your own. So I will tell you this goes down to here. If you want to squiggly line across to like tell your brain, I want you to read the situation about Lee and try to match these, right? We're going to draw lines to match. Try to match the expression over here with the situation over here. So take a moment. and then I'm going to ask you guys. If you're highlighting, 25 cents for each, right? Pre-sold 32. That's underlined because if you didn't know what the word pre-sold meant in Khan Academy, you could click on it and it would tell you like you sell before something starts. She sold C more carnations on the day of the fundraiser. So more tells us we're going to add, right? So, Sydney, will you match one of these? Let's just say like A, B, C, D and A, B, C, D. So, like, give me one on the left side and tell me what it matches to on the right side here. Yeah, so the second one here, the amount of money earned per carnation is 0.25. Nate, give me another one. Carnations. It's a flower. How many did she sell before it even started? And then how many more did she sell? Yeah, it's the first one because she sold 32 before it even started. And then she sold C more on the day of. Note, if she sold 32 before it even started and each of them gets her 25 cents, amount of money earned for Carnations Lee pre-sold, well, that's 32 times a quarter. What's a quarter times 32? That's $8. So then, the amount of money earned for Carnations Lee sold on the day of the fundraiser, well, we don't know how many it was, but she got 25 cents for every one she sold. Preguntas on this. One of my favorite Spanish words, because the rolled R, and it just is fun to say. It means questions. Yeah, we do. We have Spanish in 8th grade. Nate, you know this. We tell you this when you join Phoenix. That's funny. Hey, if you think about it, make sure you thank Mr. Kabila and Mr. Estes. They're doing the 6th grade visits this week, and it's like virtual, so it's a lot of work that they have to put in to like make it all happen. So give them a quick thank you if you think of it. Yeah, we have till 52. Sweet, I got a few minutes left. I don't know why I can't get this scheduled down, guys. Try this. The next one, it's on your paper. You don't need to look up here. You can read your paper. What I want you to do is write an expression to represent how much energy is being generated. How much energy, you listening, Nate? how much energy is being generated. Mr. Smith is actually about to get solar panels. They're a good idea. Stella, you got any thoughts for us? Wow. Wow. As my wife would say, like a cat with the claws coming out. Martin, you got any ideas for us? No? Anybody got any ideas? At this point, drawing cards just seems like I should just ask if anyone's got any ideas. Well, let's highlight what's important. 2 windmills. Okay, sweet. 3 solar panels. Awesome. M is windmill. M for mill, although it's not actually a windmill anymore. People still call it that. And S for solar panel. So we're going to use M and S. So the number 2, would the number 2 go with M or go with S? M, right? So we're going to say 2M for the amount of energy generated from the windmill. I should see people writing this. And, right, mathematically, when we say and, we add, what else? The 3, you guys told me you didn't know what to do. It sounds like you do. Now, wait. Mr. Hudson said per means divide, but that's not true in this case. Yeah. Ha ha ha. I like what you just did there. That was a bad joke, and I like it a lot. If we were given... Hey, I need your, 100% attention, because this is where, what I've taught you to memorize doesn't make sense anymore. If they gave us the amount of energy and the amount of years, and they said, figure out energy per year, we could do the division, but we haven't been given the numbers. We don't know how much energy, and we don't know how many years. Here, per is telling us how much they get, so it's like a for every, right? So we could multiply times the number of years. So if we wanted to build the entire expression here, we could say, times however many years they do this. Right? But if we were given the numbers, we could calculate energy per year. We're not given the numbers, though. Does that make sense? Do we have questions on that? / go ahead and look at Helena's expression. She lost her marbles. That's an expression for when you, go crazy. But it could also mean you dropped little glass spheres.
How do they make marbles?
I'm not sure. Alright, so Helena lost her marbles. Highlight. 4 bags. Ooh, remember when we talked about groups and what's in each group? Each bag has M marbles. And she has 3 marbles left over. So the amount of marbles, the total, right, we could say total if we wanted to. You don't have to put a T equals if it just wants you to build an expression. But, so she had 3 marbles left over. I'm going to go ahead and write those down first, even though they talk about it last. How many bags? 4. How much in each bag? M. Careful. I know my finger's still pointing at 3, but listen to the question asked. So the total would be the 3 marbles that aren't in the bag and 4 bags of M marbles. Guys, you could also write this as 4M plus 3, and it's the same expression. This brings us full... Nate, stop for a second because I need your attention. Then you can do whatever you want because we're about done. This brings us full circle back to the top of our notes where we talked about the y-intercept and the slope. The y-intercept, when you're given an equation, is this number on its own. It's the starting point. So this would be our y-intercept, the 3, the thing that doesn't have the variable. And the 4 would be our slope, is what we would call that. Now, I know you don't, that doesn't make a ton of sense yet because we aren't graphing these yet. We're going to start to graph these, and this will make more sense when we do. But the number that is describing the multiplication by the variable, that's what we call our slope. Well, thanks. I don't know if that's true, but thanks.
That's pretty fun. It's pretty fun. I'm right one of that one.
Please wipe down your desks and highlighters and rulers. Sure.